Hello, everyone. Thanks and welcome to my final presentation of IS 597 PRO class. I'm Zhou Sang, and my topic today is Age of Empires 2 Resource Gathering Simulator. So what is Age of Empires 2? It is basically a real-time strategy game that can date back as early as 1998, and players' job is to gather resources, build army, and conquer other players to win. The economy plays a very important role in this game as it is the direct foundation for any military production, and villagers can be assigned to gather different resources, but how to allocate them is the question. So the question since my childhood is, what's the optimal villager strategy to gather a specific amount of resources in the shortest time? The motivation of this question comes directly from the game, where it has 4 ages: Dark Age, Feudal Age, Castle Age, and Imperial Age. Each age is a big leap from the previous age, where it gives player higher and better techniques and can train better, stronger units. So this can be a motivation for players to upgrade to there as fast as possible. The costs for upgrade are listed below, where we can see from Dark to Feudal Age, it requires 500 food. And as upgrade goes later, the cost goes up. And several supplements for our interest in this problem. The first one is, although more villagers bring more productivity, but training villagers can take some cost, like required food, time, and house to accommodate the population. And although not directly required from upgrade here, but wood is a hidden resource because you must need wood to build farms and house. And this can add to the complexity of our problem. The third one is we also convince ourselves that between the small and infinite number of villagers, there must exist an optimal point where they can just satisfy the resource we needed. So in order to solve this question, backgrounded in the very complex system, I try to use the idea of Monte Carlo simulation early as to learn from this semester to solve this problem. Next, we will see a typical work stream of the game. In the center, we have a town center where you can train the villagers and assign them to different tasks. For example, if you assign them to a farm, it will become a farmer and collects food. If you assign them to a stone mine, it will become a stone miner. If you go to assign them to a goat mine, it will be a goat miner. And if you assign them to cut the wood, there will be a lumberjack. The resource is shown in the top of the UI, and you can see how many resources you have collected so far, and this is the population. So from this picture, we can very easily get to an idea of building superclass and called villager, where it can take max amount of 10 units of resource, and the resource type is not assigned here, but it is assigned in a subclass. The farmer is inherited from the villager, and also a lumberjack. Each of them has a different work interval to gather max capacity of the resource. So next we will talk about the implementation, and the first thing is the data structure. A main obstacle in doing this problem is it is difficult to track so many villager objects, for example, the lumberjack, the stone miner, or etc. with one global variable called time. The first naive idea we thought of is to use time package, where we can write some code like define work, and for every time slate for every work interval as self resource plus equals 10. But it is really dumb to wait in real life to see the simulation results. And even if we scale it to say 1 in 1,000, the running time of a machine will cause inaccuracy for this project. So we think this is not reliable method. Instead, we recall a structure called heap in the Coursera online course. So a heap's property is that the min element is always at the top. So as for the time complexity part, it only takes constant time to get the min element from the heap, and also insert an element takes O log n time. So we can format the event heap in this way. The first variable is time heap, And second is description. And third one, if it's a type of resource, we can add its amount. So an example heap for an event series for a farmer object would be this time it can give 10 units of food at every 32 seconds. It can give 10 units of food. So we put this all series of events as a event heap for a farmer. So for a system, there can also be a larger event heap where we have at time 0, we try to train a villager, and if the food is enough at 25 seconds, the villager will be trained. So we add all these events to the system, and we can execute them one by one by always extracting the minimum element from the heap. So this is a good data structure for this problem. Next, we go to the models and hypotheses of our simulation. Although the Age of Empires 2 is famous for its stunning details, but as a researcher, we must omit some of details and try to focus on the main problem. So the first simplification we made is that villager only spend time in gathering resource and spend no time in transporting to the resource center or getting to the work site. The reason we did this is because that although we can add some random numbers to simulate time, but it will lead to inaccuracy. And these constant numbers are just preventing us see the problem more clearly, and it have no effect on the relocation importance. Again, our key goal is to try to learn the best allocation and not to make precise simulation of the time it's used. So similarly, we have other simplifications. Second, villager can be assigned to gather only one kind of resource because we think the reassignment can be messy. Third one, only one town center is considered because we are focusing on the early game. Next one, although we said the farm cannot exhaust, but we will automatically deduct wood as proportion to the cost of build a farm. Also, we have similar simplifications. No upgrade is allowed. This means the flow is constant. And also the town center trains villager continuously at earliest possible time because the villager produced the earlier it can provide more resources. Next, we will go to the key ideas and some details. The first one is very important one, we think, that the optimal allocation for a specific villager can always be deterministically decided. Because previously we thought we might recourse to Monte Carlo simulation to run different job assignment every time and record the strategy with best time. But after a closer study, we find that we can directly calculate which kind of resources in most need. For example, we can calculate the time for a specific resource where we set it to the goal minus the current. This means the gap, and the denominator means the number of villagers. So this formula basically tells us how long it takes to gather the resource to meet the specific goal. So we can always assign the villager to with the highest evaluation score, means this resource is currently most undermined. So we can see with this function, we can dynamically set the required goal and to let the system to decide which resource should a villager need to be worked on. So we also took care of details of assigning villagers to build a house to accommodate current population. And this function shows that if there is only 2 space remaining in the current population to the max accommodation currently supported, we will the event heap will add a new event called builder and try to build a house where it takes 25 units of food. So there's other details, and we will not spend any time discussing them here. So next we will go to the most exciting part. It's running the simulation. The first question is, what would be the best villager strategy if we want to use shortest time to upgrade from dark to field age? After running the simulation, we set only need 500 food because this 200 wood, because you will be need for to building the buildings, because you also require some buildings to upgrade, and we convert the building requirements simply to the resource of wood. So after put this resource requirements into the simulator, see from 5 villagers to 30 villagers and record time of each simulation, we find this time it requires the least time. So it means just do not train more villagers, just assign your villagers you already have to get resource. This is the fastest. But the question is quite different. For example, if we want to say advance from dark to castle age, where it's 2 upgrades. So we add up the total requirements. For example, we say it's 1,300 food and 500 wood and 200 gold. So we feed this into the simulator and run the simulator. You can see the curve here, and it shows somewhere near 21 number of villagers will yield the shortest time cost. So it's pretty amazing, because in real game, pro players' general strategy is to train 21 to 22 or some number near here villagers in the dark age. This is the standard opening, as they said in this game. So we can see our simulator yield really good results to pro players' choice. And if we want to see what the specific allocation is, the labor division dictionary tells us there is 12 villagers in food and 7 in wood and 2 in gold. So this number can provide some guidance to us if we want to play this game in future as to what would be the best numbers to start a game. Next, we continue to see some other simulations. What if we say what's the best strategy if we want to upgrade from to Imperial Age with also a castle, where a castle needs 650 stone. So we can add resource requirement here, where it needs this food and this wood and this gold and this stone, and it will draw us a curve. And this time it tells us somewhere near 35. This is a good answer, because the time cost is really high here, and this is dramatically goes down. So if you want to later game, the number of villager might be higher than before. And this also shows the labor division of this many to food and this many to wood. The last question was the best strategy if you want to upgrade to Imperial Age with the big army. So this time we require more resources, as training big army can be very costly. So we directly set this a number to 5,000 food, 4,000 wood, and 4,000 gold. So this time it tells us the non-villager should be somewhere near 45. And this time again, it's coincidence with the AI strategy. You can see this is pretty much the number of villagers of hardest AI when I played Age of Empires in my childhood, when the population limit is 75. So it again gives some proof on the accuracy of every experiment. So in conclusion, I think this is a very fun experience. At the beginning of project, to be frank, I had only a vague idea, and I was not sure about what structure to use, or whether I can implement the simulator, or whether it's accurate or not. But I spent most time on is the data structure part. But after having the idea of a heap, everything else goes rather smooth. I also generate a lot of new ideas during my coding. All in all, I really enjoy this experience, and I think I'm really interested in using programming to model and explore and to solve real-world problems. On the other aspect is wish from the childhood fulfilled. As a child, I always wondered what the best strategy is for such a problem, and now I finally come to a solution through my own efforts. Previously, I thought it required a lot of math knowledge and recursion research knowledge to use a lot of differential equations or something. But I find my Python simulator works just fine to solve the complex system. Last, I want to thanks to Mr. Weibo for his enlightening course, and I really learned not a lot of knowledge and had much my coding confidence and capability has grow, and this is something I was really happy about. So at last, thanks everyone for your watching, and please contact me if you have any questions or ideas. Thank you.